Okay. Hi, we're going to look at problem 5102 and 5105. They're asking for x and y of the same problem, and it's this composite body. We have this machine element shown, and we're supposed to locate the center of gravity. Okay, so we have this thing, and it's in 3 dimensions. So we're going to break this up into individual bodies. We're going to have body 1, which is this bottom plate, body 2, which is this plate sticking up here, body 3, which is this cylindrical thing poking out, and body 4 is this hole here. Okay, and we are just going to go through and fill out this table that we do on all the other ones. So here, I'm going to even zoom in a little bit, see if I can make that a little bit more readable. And so let's start with body 1. What is body 1? Well, it's 100 by this 20 plus 25 plus 25 plus 20 is 90 by 18. Okay, there's body 1. What is x bar? How far along the x-axis is the center of gravity? Well, it's going to be half of 100, which is going to be 50. The y bar, how far along the y-axis? It's going to be half of 18, which is going to be 9. And the z, how far along the z-axis? It's half of 9, which is going to be 45. Now this x bar, v, all this stuff, this is pretty standard stuff, and this is why we're using Excel, because we're going to say this is equal to x bar times volume. Boom. So here's now a little Excel trick. If I drag this over here, it's not going to work. And it's because if you look at this, this is times B3. This is going to want to multiply it by C3, and that's no good. But I'm going to come in here, and there's this little thing in Excel. You can put a dollar sign in front of that. And then what that'll do is it'll make it so when I drag it across here, when I copy it over here, each one will keep on pointing at B3. But it's nice enough that if I drag it down here, it'll point to the next column. So it'll fix this column, but it'll point to the row, appropriate row. So that's body 1. Let's look at body 2. It's this portion right here. So this thing is what, 50 wide. The volume is going to be 50 wide by 60 high by 16 deep. Okay. What is the x bar of this one? How far along the x-axis is this? Well, it's going to be 100 minus 16 plus half of 16, right? So we can just do this math here in Excel. That's a nice thing. We can do 100 minus 16 divided by 2. So it's going to be 92 to the center there. And the y-axis, it's how far up is it? Well, it's going to be, again, the nice thing is we can just use Excel to do this math. It's going to be the 18, because we're going to start at this 18 plus half of 60, right? So 60 divided by 2. And then in the z-bar, how far out in this z-axis? That one's actually relatively easy. It's just simply 45. Now let's look at body 3, and this thing, notice this already populated for us, which is awfully nice of Excel. Thank you. And let's look at body 3, this little cylindrical thing sticking out. The volume of a cylinder is the area times its thickness, right? So it's going to be pi, that's how you do pi, is pi parentheses parentheses, times r, which is 12 squared, times the thickness, which is, looks like 10. So that's our volume of that. What is the x bar? How far along the x-axis? Well, it's going to be 100 plus 10 divided by 2, or 5. We could have probably just wrote 105, but you know. How far up in the y direction? Well, it's simply to the center point here. So since we'd have to do a bunch of math because it's going to be 18 plus 60 minus 24, let's just let Excel do it. 18 plus 60 minus 24. I mean, you can plug it into your calculator, but why? Excel's right there. Okay, and lastly, z, how far along in this direction? Again, that's surprisingly convenient. It's 45. Okay, there we go. So we have it in that direction. And then lastly, this little hole right here. So what is the area? Again, it's pi times r. In this case, it's 13 squared, right? Times the height, which is times 18. Okay, but there's something very important here, and that is that this needs to be a negative because this is a hole. It's missing that. Okay, what is the x bar of that hole? It's 28, it looks like. It's just given to us right here is 28. The y bar is halfway up, so what is that going to be? 9. And the z bar is, hey, it's the first thing that's not symmetric. So the z bar, if this is, it's going to be 90 minus 40. Again, I probably could have just figured out that that was 50, but might as well let Excel do this math. So now we have this nice table figured out. We need to fill in the sums. So here we'll take this as equal to the sum of that. We'll drag this across here, and then just for giggles, so we don't confuse ourselves, we'll get rid of those because we don't care about those. And so now what is our x bar? Well, our x bar is simply that divided by the volume, Boom. Our y bar is same deal. It's equal to that divided by the volume. And our z bar is going to be equal to that divided by the volume. Boom. So you'll notice the z-bar is just barely short of 45, which makes sense because quite frankly they're all centered except for this one's a little bit over here, so it's a hole, so it's going to move in that direction. Our x-bar is 62, so if it was just this thing right here, it'd be roughly in the middle, but since it's going to be combined with a little bit of weight over here, okay, fair enough. And then the y-bar is 19, so it's going to be slightly above this point. And you'll notice this is out in the middle of space, right? This is not on the body. That this is going to be floating somewhere back in here. It's not going to be attached, and that's fine because the whole point of this is that it doesn't have to be on the body. It's if you were to model this as a single point in space, that's where you would model this object is right there. And let's compare notes. 19.13, lovely, and for 105, the x is 62.1, lovely, and for some reason they don't do the z-axis. But there we go. So again, please feel free to do this in Excel if you want to turn this in Excel. To me, this just makes sense. It lends itself very nicely to Excel. You can make it pretty, put a little surround it, and here are your answers. So there you go. That is that problem done.